Hi everyone. In this video I'll be showing how we can integrate different data along a horizontal well to model stage performance based on several different variables. These could be engineering, geological, or geophysical data. In this dataset, I've got several well pads drilled to the Montney Formation, but I'm just going to be focusing on these 6 wells here. Now I've loaded in my frac stage data as well zones, and we can see those as these little orange ticks along my well bore. What I'm going to do is take a look at these several different properties that I have along my well bore. It could be log curve data, could be some engineering data that I've loaded in, like rate of penetration, or it could also be seismic property data. For example, I have a seismic property map here over my area where it overlays these 6 wells. And so the first thing I'll do is extract along each of these horizontal well bores the data from this grid. To do that, I'll open up my well intersections tool first and select my 6 different wells that I want to be using. And I'm going to be intersecting with a grid here along the well zone for this horizontal interval. And I'm going to be using a seismic property grid here. And then I'm just going to output it to a log curve named property. And I can run that. While that's going, I can come back to my map and I can also take a look at some of the different curves I have loaded along my horizontal wells. So I've got rate of penetration in this rainbow color, and I've got a gamma curve loaded here as well. And I can take a look at all of these different variables in my log editor. But what I really want to do is compare how these different log curves vary in each different zone that I have, and compare all that data to each other so that I can model different performance attributes along my horizontal wells. So going further from that, now that my intersections are all calculated and I've got my log curves output, I can come over to my log curve well zone attributes, select my wells once again, and in this case I'm going to be looking at an interval over all of my different well zones. And in this case they're just called frac and the type is completion. And I'm going to select my different log curves. These could be anything that is loaded or referenced to measure depth along your horizontal well bore, but in this case I'm going to use mud gas, my gamma, that property map or the property curve that I extracted, as well as rate of penetration. And I'm going to take a statistical measure of each of those curves within every different zone. So in this case, I'm just going to look at average, but I could look at medium, min, max, or sum, because I'm going to be doing some analytics on this to get an idea of how things compare. So I'll just set it to average, and when it runs, so it goes pretty quickly, I can take a look at my well zone properties. And in this case, I've got a table of different values within each of those different zones. So I've got my frac zone, top, and base MD all along it, and those 4 different properties. It's great that I can see those different properties in here and look at the different numbers, but it's really hard to wrap your head around how each of those variables might compare. So what I'll do is export these well zones to a CSV file. And I've actually done this ahead of time, so we don't have to worry. But then I can come over into a little Python script I've written up. And using this, I can, using the Seaborn library, specifically along with pandas and matplotlib in Python, I can generate a pair plot that gives me a really easy and quick way to compare all those different variables. In this case, I'm using basically synthetic data, so there's not really any great correlations here, but you can try it out with your own data to see what kind of variables might be the most important or might be the most relevant along your horizontal wells that you can then use to model your different stages. Thanks, that's all for me today, and we'll see you next time.